Hello students, welcome back to my YouTube channel Data Shah. In today's lecture, we'll be talking about the rank of a matrix. So I have started a new series in which I'm talking about the solutions of the system of linear equations. So in the previous lecture, I have given just a brief introduction. What is the system of linear equations, the types of linear equations, and what is homogeneous and non-homogeneous linear equations, and how you can find out the solution of the system. So for that, we need to understand what is rank. So let me first introduce with you what is a rank of a matrix. So the matrix is said to have a rank R, or we have another notation. So I'll be talking about it. So let me just write mm, the rank of a matrix A is defined as or, and is denoted by R, or we have rho, the rank of A. So these are the different notations that you could see, or it would be R of A. So these are the different notations that we have for a rank of a matrix. So it is the rank is said to be R if, so we have certain conditions. So let us consider that if there exists, first point, at least one, mm, sorry, at least a non-zero minor of order R. Second, every minor of order greater than R must be 0. So then we could say that that's the rank of the matrix, that is R. Now, also we need to keep certain things in mind. So let me just write down as a note. So the first point, the rank of the matrix denotes the total number of um, let me just write it correctly, linearly independent rows in the matrix A. That means we are talking about the non-zero rows in the matrix. So when we'll be performing the elementary row operations, and we'll be talking about the echelon form, right? So we are reducing the matrix in an upper triangular or a lower triangular matrix. So what we'll be doing after changing, converting it into the upper or the lower triangular matrix, we'll be calculating the number of the non-zero rows. So those that would be your matrix. That would be the rank of the matrix, sorry. So there are two ways. First, the rank of the matrix denotes the total number of linear independent rows. And second, the rank of the matrix denotes the total number of non-zero rows after reducing the matrix um, to the echelon form. using elementary row operations. So this is what we have. Now, we'll be taking a question so that it would become more clear to you. So let me write the question. Find the rank of the matrix. So the first question that we have is a 3 cross 3 matrix I'm taking. So in this, because I'll be applying the elementary row operations to reduce it to the upper triangular matrix. And as we know, the upper triangular matrix is of the form upper triangular matrix is written like this. So you have A, B, C. So this is the upper triangular matrix, okay? So you can refer to this. This is your upper triangular matrix. So my concern is to convert this into an upper triangular matrix. That means I have to convert these elements 0. So I'll be starting with the first column. So to make the first column 0, I'll be taking certain elementary row operations. So let me take, so row 2, because I have to make this 0, this element. So, and okay, let me just erase this. Yeah. So this would be row 2 minus twice of row 1. So this is just the symbol to show this is equivalent of this. So no changes in row 1. So row 2, 2 minus twice of row 1. So it would be 0. 6 minus 8, right? Because what is twice of 4? That is 8. So 6 minus 8 would be minus 2. 8 minus 10 would again be minus 2. So this is what I'm getting. Now to make this element 0, the row operation would be done in row 3. So row 3 minus 3 times of row 1, because only then this would become 0, right? So 7 minus 12, so that would be minus 5. 21 minus 15, so that would be 6. So this is what I'm getting. Now, what I need to do in this, first of all, I'll be doing the elementary row operation on the second row, where I'm dividing this particular row by minus half. So I'm getting this as 1, 4, 5. No change in row 1. No change in row 3. Only change would be in the row 2. So 1 and 1. In the elementary row operations, that means if you are reducing it into echelon form, you need to make it to 1. This is how we used to do it. Then moving ahead. Now, the elementary row operation I'll be taking would be in the row 3, because I need to make this element. I need to make this element 0, right? So that would be my row operation now. So row 3 plus row 5 times row 2. So this would be equivalent of no change in row 1, no change in row 2. Row 3, this is already 0. This also 0. And the third element was 6. So 6 minus 6 plus 5 would be 11. So I'm writing this as 11. So now you would notice that this has been converted to an upper triangular matrix. And now, what would be the rank? Coming back to the definition of the rank, I told you the number of non-zero rows. So you could see here the number of non-zero rows are 3. So as there are 3 non-zero rows, so the rank of A would be equal to 3. This is how we could find out the rank of a matrix. This is very easy to find out, right? And We can have a 4 cross 4 matrix also, and we could find out the value for that as well. So let me take another example. And here I have, let me take the matrix B. Let me take a 4 cross 4 matrix now. So using the same, I need to make them 0. So I'll be taking the elementary row operations. Row 2 goes to row 2 minus row 1. Then for row 3, it would be row 3 plus row 1. For row 4, it would again be row 4 minus row 1. And what I'll get here, 1, 0, 0, 0. Now, first row remains the same as you have noticed. The only difference would be in the, oh, I'm sorry, the only difference would be in the other rows. So 1 minus 1 again 0, 1 minus 0 is 1, this is 0, 1 plus 1, 2, 1, 2, this is minus 1, 0, and this is 0. So this is what I am getting here. Okay, so let me just shift it. So this is what I am getting after the first set of elementary row operation. Now what needs to be done? Now I will be shifting this particular 2 in the upper row, and then I would be converting them equal to 0. So let me just write here. Row 2 is interchanged with row 3. So I am getting here. First row will remain as it is. Second and third rows are interchanged. So I'll get, so this is my third row, as you could see, 0, 2, 1, 2, and 0, 0, 1, 0 would be my third row, and last row would be 0, minus 1, 0, 0. So you could see this 0, minus 1, 0, 0, no change. Now what's need to be done? You need to make this 0 because this is already 0. So nothing has to be done there. So row 4 goes to row 4. Plus half of row 2, right? So even you can convert it into just divided by 1, divided by 2 and make it 1, or you can use this elementary row operation. So I am doing it in both the ways. So in the previous example, I have divided that particular row with 2. Now I am not doing it. So you can do with that particular elementary row operation as well. So 0, 0, 1, 0. All the 3 rows would remain unchanged. Now this is minus 1 plus 1, this becomes 0. Now this is 0 plus half. This is 0 plus half of 2, that is 1. So this is what I'm getting. Um, now the last part that I need to do is I need to make this 0. Okay. So how could I make this 0? So I'll be using the elementary row operation for the row 4. Row 3 divided by 2. So I'll get 1, 1, 0, 1. No change in the upper rows. And so this is 1 only. So again, I'm getting 4 non-zero rows. So the rank of this matrix, thus the rank of this matrix is 4. So this is very easy to understand. So this is how we can calculate the non-zero rows. And let me take another example where you would find out that you could have rank less than the order as well. So let me take a third example. So again, this is a 4 cross 4 matrix. So now using the elementary row operations, I need to make these 0. Okay, so row 2 goes to row 2 plus twice of row 1, 3 times of row 1, row 4 goes to row 4 plus 5 times of row 1. So this would give me no change in the first row. Okay, now how to get this? Minus 5 plus twice of this. So that's 4. So this is minus 1. Then this would be 1 plus 6, that's 7. 2 minus 4, that is minus 2. Now coming to this elementary row operation, row 3 plus 3 times of row 1. So minus 8 plus 6 is minus 2. 5 plus 9 is 14. 2 minus 6 is minus 4. Last row, row 4 plus 5 times of row 1. So minus 12 plus 5 times of 2, that is 10. Minus 1 plus 5 times of 3. So 15 minus 1 is 14. 6 plus 5 times of minus 2, that is minus 10 plus 6. So that's minus 4 again. Now, we need to make in the second column, we need to make these 0. Okay, so let us consider this. Row 3 goes to row 3. So consider this. You can't add, right? So we'll be subtracting using this. And row 4 also, we'll be taking the same. So the matrix would be the first 2 rows, no change. These become 0. So now row 3 minus twice of row 2, right? This is what we have to do. Now this is 14. So this is 14 minus twice. The corresponding element of the row 2 is 7. So twice of 7. So that's coming out to be 14 minus 14. So that's again 0, what we are getting. Now minus 2 and sorry, this is minus 4 and this is minus 2 times of minus 2. Okay, so this is getting minus 4 plus 4. Again, we are getting a 0. Okay, because here you could see that it's a twice of the other row because it is a multiple. And similarly for the other fourth row is also a multiple of the second row. So I'll be getting a 0 here again. So you could just remember this. Now, what are the number of non-zero rows here that you are getting? Here, the number of non-zeros rows. So let me just write this here. The number of non-zero rows are just 2. So thus, the rank of the matrix is 2. So it's always not necessary that you will be getting the same number as the order of the matrix, right? It could be different. Okay. So this is how we can find out the rank of the matrix. And in the next lecture, I'll be talking about the system of the linear equations, how you can find out their solutions using this rank method. Thank you so much, everyone.